What's up everybody? In this video, we're going to explore how we can change the frame displayed on the LED matrix when we press a button. This will give us some interactivity to our LED matrix. Before we start coding on the Arduino, we want to build our circuit. We'll do this by connecting a button to pin 2 on the Arduino. Connect one leg of the button to power, and the other leg should connect to the ground using a resistor. The resistor used with the button is a 10 kilo ohm. Connect a wire from the leg with the resistor to pin 2 on the Arduino. Before we get into coding, let's discuss how our circuit will work. We will have a single button on a breadboard. When someone presses it, we want to change the frame that is displayed on our LED matrix. So in our program, we want to capture the moment the button has been pressed. Once pressed, that is when we will execute additional code to update the frame. To do this, we are going to track and read the current and previous value of the button with each iteration of the loop. We can compare the values to detect when the button is pressed. Open the Arduino IDE and create a new sketch using our template we created in Tinkercad. Fill out the information in the header of our code. Update the program name and description. The program name is LED Matrix Interactive Frames, and the description is a sketch where we will change the frame displayed on the Arduino LED matrix when a button is pressed. Declare the variables. Add int button pin equals 2 semicolon to declare the pin that the button is connected to. Next, we will create variables to store the current and previous state of the button. Type bool current button state semicolon and bool prev button state equals low semicolon. In the setup function, we need to tell the Arduino that the button is an input. Add the line pin node, open parentheses, button pin, comma, input, close parentheses, semicolon. In the loop function, type current button state equals digital read, open parentheses, button pin, close parentheses, semicolon. This will update the current button state variable with the state of the button. Before the end of the loop, type prev button state equals current button state, semicolon. This will update the previous button state with the current button state. Next, add if, open parentheses, current button state equals high, and prev button state equals low, close parentheses, open curly brace, close curly brace. This conditional statement checks for 2 conditions. The first is if the current button state is high, so it has been pressed, and we compare to the previous value of the button. It should be low. Update the delay to 75. We are setting up our loop in a way that will only execute code at the moment when the button is pressed. If someone presses and holds the button, it should only execute once, because we added a second condition that the previous state had to be low. Inside the curly braces, add serial.println, open parentheses, open quotation mark, button pressed, close quotation mark, close parentheses, semicolon. Upload your code to the Arduino and ensure you have the serial monitor displayed. Try pressing the button. You should see that when you press the button, the words button pressed show up. But if you press and hold, it only appears once. Now that we have read the input from the button, we will add some code to send a frame to the LED matrix. Load the library and declare the variables for the LED matrix. Type hashtag include, open quotation mark, Arduino underscore LED underscore matrix.h, close quotation mark. Next, we will need to create an instance of the LED matrix. Type Arduino LED matrix, matrix, semicolon, after loading the libraries. In the setup function, we will initialize the LED matrix. Inside the curly braces, type matrix.begin, open and close parentheses, semicolon. Now we will load a frame. Type matrix.loadFrame, open parentheses, LED matrix underscore Uno, close parentheses, semicolon. The frame I'm referencing are frames designed by Arduino and are available through the library. I have a link in the YouTube description where you can see the Arduino documentation. Upload your code to the Arduino and ensure you have the serial monitor displayed. You will see an image of the Arduino Uno displayed on the LED matrix, and it is detecting when a button is pressed. Next, we are going to create a variable to count how many times the button has been pressed. In the variables section of your sketch, type int counter equals 0 semicolon. Then, in our loop function, inside our if statement, we are going to update the counter. Type counter equals open parentheses counter plus 1 close parentheses percentage sign 4 semicolon. Next, add a serial.println open parentheses counter close parentheses semicolon to debug. Looking at the counter statement, you can probably figure out what the counter plus 1 will do. However, the percentage 4 is something new. What we are doing is setting an upper limit for our counter. If the counter gets to 4, it will reset to 0. So we will have the range for our counter to be 0, 1, 2, or 3. If we want a higher upper limit, you can change the 4 to a higher number. What does the percentage 4 do? It performs a modulo operation, which gives us the remainder when the two numbers are divided by one another. In most cases, we will not get a remainder. However, if we get a remainder, for instance, when the counter gets to 4, we will have hit the upper limit of our counter and it will go back to 0. Upload your code to the Arduino and ensure you have the serial monitor displayed. Each time you press a button, you will see that the counter goes from 0 to 1 to 2 to 3 and back to 0. To change the frame displayed on the screen, we are going to use a switch statement. A switch is similar to an if statement, as it allows you to evaluate a variable for conditions. After the delay, add switch, open parentheses, counter, close parentheses, open curly brace, close curly brace. This will create a switch statement to evaluate our counter variable. Next, inside the curly braces, add case 0, colon, and below add break, semicolon. For each possible scenario where we want to execute code, we will write a case. For our program, we will create a case for 0, 1, 2, and 3. The break will end processing of the switch in each case. Before the break, add matrix.loadFrame, open parentheses, load matrix underscore uno, close parentheses, semicolon. Next, copy the case and paste it 3 more times. Update the case so we have case 1, case 2, and case 3. Last, change the name of the frame that is loading in each. Upload your code and see what happens. You should see the Arduino Uno image load on the LED matrix. Then, when you press the button, the frame will update with new frames. It will cycle between 4 different frames. You can add additional frames or additional cases if you want to have more frames. Let's do one last thing. We are counting up from 0 to 3. What if we want to count down? In my sketch, I'm going to have code for counting up and down. Copy and paste counter equals open parentheses counter plus 1 close parentheses percentage 4 semicolon and comment out the first statement. In the second statement, we will change the plus to a minus. Upload your code to the board and see what happens. It isn't doing what we want it to do. You will see in the serial monitor that we are getting values 0, -1, -2, and -3. Since we do not have negative numbers in our switch statement, the frames aren't changing. So how can we fix this? We need to make a small adjustment to the counter to account for negative values. Add if, open parentheses, counter is less than 0, close parentheses, open curly brace, counter equals 3, semicolon, close curly brace. Now, if the counter subtracts and goes below 0, it will adjust to 3 and count down from 3, 2, 1, and 0. Upload your code to the board and see what happens. Now when we press the button, we are cycling through the frames, but in reverse order. Cool! We can now add some interactivity to an LED matrix animation. At the end of this video, you should be able to change a static image that is displayed on the LED matrix of your Arduino when you press a button.